Hello students, we are in assignment 10.8 and in this video we'll address three questions out of four. Very first is define plane of vibration or plane of oscillation, explain what is unpolarized light and polarized light, and we'll also see what is dichroism. So let us start. Now we know that in any electromagnetic wave, in any light wave which is electromagnetic, we have electric field vectors and magnetic field vectors. Now, when you draw this diagram, what you are trying to convey is that electric field vectors are oscillating in the direction indicated by this arrow. And if you are far away from the source, then magnetic field would be oscillating like this. So magnetic field is perpendicular to the electric field. Okay, and this disturbance propagates. So when we say that in any region you have electromagnetic wave, what essentially you are talking about is there is change in electric field and magnetic field in the region from where electromagnetic wave are passing. So what is the nature of this electric field and magnetic field? If I say that this is the direction of wave propagation, then electric field vector may be oscillating like this. Now the light effect which we sense in our eye is because of electric field, so I'll not be talking about magnetic field. Now, the only condition on electric field vector is to oscillate perpendicularly to the direction of wave propagation. But for the given line, there are many options in which electric field vector can oscillate. For example, this is one situation, one possible situation. But you can also have electric field vectors oscillating like this. So here electric field is oscillating in a direction perpendicular to the plane of the screen. Now you can always have electric field vectors oscillating in different plane. So how do we know exactly how electric field vectors are oscillating? Now in ordinary source of light, electric field vectors are oscillating in all possible planes. So if you view from this point, then you will find that the electric field vectors are oscillating like this. Electric field vectors are oscillating like this. Electric field vectors may be oscillating this way or in this plane. Okay, this dot is indicating that light is coming towards us. So all these are possible planes of oscillation for electric field vectors. Okay, and if we see that in any light, electric field vectors are oscillating in particular plane only, then that light is called polarized light. So here, in this case, I can say that this is the plane of oscillation, whereas this is the plane of oscillation for this wave, and this is the plane of oscillation for the third wave. And plane of polarization is plane which is perpendicular to the plane of oscillation. So two definitions here. What is plane of polarization? What is plane of oscillation? Plane of polarization is the plane perpendicular to the plane of oscillation. Plane of oscillation of electric field vectors. And two more definitions. What is polarized light? What is unpolarized light? Polarized light is the one in which all electric field vectors are oscillating in random plane. So you may indicate it this way, or else this is how we can represent unpolarized light. Unpolarized light. Sorry, polarized light is the one in which all electric field vectors are oscillating in same plane. So that is all about polarized and unpolarized light. And there are certain crystals on which if you allow this type of unpolarized light to fall, the transmitted light would be polarized light. They absorb. Suppose if they allow this electric field vectors to pass through it, then all the other electric field vectors will be absorbed by those crystals. And this effect is called dichroism or birefringence. in which electric field vectors oscillating in particular direction only are allowed. So transmitted light is polarized and other light is absorbed. So that is all about polarized and unpolarized light, plane of polarization and plane of oscillation. Thank you.